So moving to the next question here, again a question based on series, the series related to binomial coefficient. See, here I will be discussing it with the help of general term method. How? See, let's rewrite. The general term method actually says, or it demands, that you get rid of any factor which has r, the variable of summation, whether it is a denominator or it's a numerator. And for that, what we do is we just open NCR, we get it as n minus r factorial into r factorial, and we already have 1 upon r plus 1 into r plus 2 here. Okay, now if you people observe that we can merge it with r factorial. So what I can write? So summation of 2 raised to the power r plus 2 into n factorial over n minus r factorial into r plus 2 factorial. Now in the entire method, the process, this term holds the key bachcho. Okay, so we can't change it. So how will we manage? And of course the target is to rewrite it as one or the other binomial coefficient term. So what we can do, I'll be multiplying numerator, and to balance it, the denominator by 1 upon n plus 1 into n plus 2. So multiplying both numerator and denominator by n plus 1 into n plus 2 here, and of course n plus 1 into n plus 2, that's independent of r, so you can, and it appears as product in the denominator, you can take it out of the summation. So what are we going to get here? So 1 upon n plus 1 into n plus 2 into, now you can write this entire term as n plus 2 cr plus 2 into 2 raised to the power r plus 2, where r goes from from 0 till n, and that's it. Okay, now if I expand the summation, so we have 1 upon n plus 1 into n plus 2. See, now if you go with this expansion, 1 plus a raised to the power n bachcho. Okay, now what can you write for it in like in terms of summation? It is nothing but a raised to the power r into ncr. R goes from 0 to n. Okay, that's exactly the same thing here. The only difference is that r plus 2, let's replace r plus 2 by new variable, so it's not required. When you put r is equal to 0, the first term you get here is c2. Okay, so what are we going to get? So it is 1 plus 2 raised to the power n plus 2. From where we got the power? The superscript. The superscript of binomial coefficient tells us the power of the binomial here. Okay, the index of the binomial. Okay, so that's it. But we are missing two terms. Which two terms? Because as I said, when you put r is equal to 0, the first term you get here is n plus 2 c2. So we are missing n plus 2 c1 and n plus 2 c0. Okay, so when you put n plus 2 c0, so that is minus 1, but for n plus 2 c1, it has to be 2 into n plus 2 c1. Why? Because the power of 2 also varies. So it is 2 raised power n into n plus 2 c1, 2 raised power 0 into n plus 2 c0. These are the two terms which were missing there. So you just subtracted them. So 1 upon n plus 1 into n plus 2, 3 raised to the power n plus 2 minus 2n minus 5. That should be the answer. So anyone got this answer with any other method? You should definitely tell me with the help of the comment box here. Okay, so that's the method which I gave you from this side as a solution. Okay, and you can definitely tell me your own method with the help of which you would have solved this equation, if there is any alternate method you have in your mind.